Welcome back to the channel, everyone. It's great to have you here. My name is David, but my girlfriend thinks that I should go by Bee Guy Dave, so maybe I'll try that out. Anyways, in this video, I want to go over these double deep frames. This is an idea that I came up with last year, and it works really well in my new hive design. And essentially what it is two Langstroth deep frames that utilize a sliding dovetail so that they can be split apart when it comes time for honey harvest. But before I get too much into the nitty-gritty about these kind of frames, and I'm actually going to go into detail about how to make these later in the video, I want to talk about why we use frames in the first place. Now, beekeeping is a practice that dates way back into ancient times. There are actually cave drawings found in Spain from about 9000 BCE that depict a man hunting for wild honey. And this is long before bees have ever been domesticated, and we kind of just scavenge for the honey. And then in about 2500 BCE is the first documented case of domesticated bees in Egypt. And it's hypothesized that China domesticated bees even before that. So beekeeping has been around for a very long time, but before frames were invented, the only way to harvest honey was to destroy the hive. And they would go in and cut down all the comb, and it's very destructive and really not good for the bees at all. So in 1851, Lorenzo Langstroth developed the Langstroth hive, and it's one of the most popular hive designs out there today. He actually lived in Massachusetts, where I am right now, which is pretty neat. But he developed these Langstroth Frames, is what they're known as, and these are all over the world. The brilliant concept that Reverend Langstroth came up with was this idea of bee space, and you may have heard of this before. It essentially states that any space in the hive under about 1/4 of an inch, the bees will fill with propolis, and then any space above roughly 1/2 an inch, the bees will fill with honeycomb. And so that leaves this gap of which bees will comfortably live. Reverend Langstroth designed his hive around this idea of bee space and created frames that would space the comb apart by about 3/8 of an inch, which is that perfect bee space. And this allowed comb to be built in nice orderly rows and allows you to remove the comb for honey harvest, but also to perform hive inspections. And it's really easy to check for disease and pests. And being able to check for disease is super important these days. It's actually in the Massachusetts General Laws, Chapter 128, Section 33. I looked this up because I wanted to know. It states, "No person shall knowingly maintain a colony or colonies of honeybees in hives, other receptacles, trees, or other lodging places in which brood combs are fastened to the container of the colony or cross-built." So essentially what that means is you have to have removable frames in your hive. Langstroth's frames were such a good idea that they literally turned it into a law. Now, I built this model of a Langstroth deep frame. This is pretty standard dimensions of what you'll find out there. And there are a couple things about this frame design that aren't quite ideal for someone who makes their own hive or has a backyard shop. The first being that some of these cuts are rather intricate. There are these stopped cuts on the sidebars. There are some tricky dado cuts, or rabbit cuts I should say, on these top bars. And overall I think they're very beefy. You know, they're definitely not going to break, which is a good thing, but they use a little bit more material than I think they need to. The second drawback with this design is this is the deepest frame that you can find for a Langstroth hive, and it only measures about 8.5 inches. It only measures about 8 inches of actual comb building vertical capacity. This may not matter if you live in a warm climate, but if you live in a cold climate like I do here in Massachusetts, when bees cluster, their cluster can actually get up to 12 or even 14 inches in diameter. And that just won't work with an 8-inch comb. And so these frames end up being a little too short to overwinter effectively. So most beekeepers around here actually have 2 levels of these, but then there's an air gap where there is no comb, and that inhibits bees as they move up and down in the hive. So this frame, while it's really great for a lot of situations and a lot of beekeepers, isn't quite what I'm looking for because it's not very good at overwintering bees. Since a Langstroth frame is a little bit too shallow, why don't you just increase the depth? So I have here the same width, the same thickness. These frames hold each other about 1 3/8 inches apart, which leaves about 1 inch for the comb and about 3/8 of an inch for the bee space. But this frame has about 17 inches of comb depth. The bees will build their comb right around this center dowel, and that allows plenty of room for overwintering colonies, and they'll spread out along the frames and have a nice big cluster. As they consume their honey stores, they'll work their way upwards, and 17 inches is plenty for this climate here in Massachusetts. This is a great frame. These do get heavy if they are fully laden with honey, but since you're only picking up one of these as opposed to a box of 8 or 10 of these Langstroth Deeps, you know, the weight isn't that big of a deal, at least for me. The only drawback with this type of design is that you cannot put this in a honey extractor. There's no way that any honey extractor you buy off the market, at least in the United States, is going to fit a frame with these dimensions. It's just too big. So you could cut the comb and strain it, but that's wasteful. Comb is very, very valuable to the bees. It takes about 8 pounds of honey to make 1 pound of wax, so they really have to work hard and use a lot of their resources to build out wax. So I want to preserve as much of that hard work as possible, which is why last year I came up with my first double deep design, and that is this guy right here. It features removable halves so that each half can be put in a standard honey extractor. Each of these is the equivalent of the Langstroth frame. So these are fully compatible with honey extractors out there. And I really like this design, and it's actually what I have in my backyard right now, working quite well. But there are certainly some improvements that can be made on this design. First of all, I think I overcomplicated this a little bit. I made the top, I'm calling this the hanger removable, because I wanted both the top and the bottom frames to be interchangeable. And that way you could put a frame from the bottom to the top and vice versa. But what I've come to realize is that's not super helpful. There are only a few cases in which you want to do that, and honestly, when you're out on the hive and there are bees buzzing all around, the last thing you want to do is pull these apart and disturb all those bees just to flip the orientation. So that aspect I can get rid of on this new design. And then secondly, it's just a bit chunky. It's kind of similar to these Langstroth frames, where I wanted them to not break and be very durable. But at the same time, I think I went a little overboard, and it leaves about 1.5 inches of wood on this middle section. That's a space that the bees can't build their comb, and it really prevents those bees from having free range over this entire area, which is what I want, because I want them to be able to cluster in the winter for these hives. Having said all that, I have come up with my new design, which is this guy right here, the Double Deep 2.0. It features, once again, 2 frames, both the equivalent of a Langstroth Deep frame. And when you put them together, they slide on nicely like that. This dimension is much thinner. It's only about, what is it? It's only about 3/4 of an inch now, as opposed to 1.5 inches. And yet it retains a lot of the rigidity that was in that old design. I do not think these will break. I've also simplified the joinery on a lot of these. I don't want to make intricate cuts. I know I've explained that in other videos. But this, I think, is going to work out really well. I've got grommet holes so I can put wires in. I've got grooves in the top. I plan to put in starter strips. I don't use foundation, but if you were to use foundation, you could easily slot that in here and it'll work out fine. The dimensions are the same as a Langstroth frame, so a Langstroth Deep foundation would work really well. The other change is I now have a permanent top and a permanent bottom, so I can no longer flip them, but you know, that doesn't really matter to me. I'm going to be happy with how the bees decide to allocate their resources. I think they know best. And then one last change that I made is instead of having slots in the hive to space the frames apart, these frames are actually self-aligning. So these top bars butt up against each other, and then I have these spacer pieces down below that will hold these frames at the perfect 3/8 of an inch spacing, providing adequate bee space and allowing the bees to move freely while building the comb as designed. So I think this is a very elegant solution. The joints are simple, the cuts are easy. Now, I won't sugarcoat it. These frames take a while to make. I spent several hours making just the 25 I need for one hive, and it was truly a labor of love. You know, there are a lot of joints on this. There are twice as many joints as a standard Langstroth frame. Granted, you're getting twice the comb capacity, but you can't buy these, so you kind of have to put the time in if you want to use them, and I think they came out well. The only real challenge is setting up and cutting this dovetail accurately. You want somewhat of a loose fit when you're in the shop, because once you put these in the hive, all that moisture in there is going to make the wood swell. So you want a little bit of slop when you make these in the shop, and that way when they swell in the hive, they're going to be a nice fit. I hope you've enjoyed this brief overview of kind of the progression of how I got to this design. If you have questions, please let me know. But I also want to show you how I actually made these. I have plans available for sale on my website, but the actual procedure I think can be helpful to go over. So let's make some sawdust. Now, the next step with these sidebar pieces is an optional one, but I'm going to go ahead and do it, and that is to drill holes for grommets. This is only necessary if you're going to wire your frames. I probably won't wire all of mine, but I want to have the option to, so I'm going to do that now. The hole you drill will really depend on what size grommets you have. Mine work out. I'm drilling a hole about 0.1 inches in diameter. I've listed on the plans for 1/8 of an inch, but just know that you should size that to whatever grommets you have. And it's really convenient to do this step now because you can get all of the frames that we're going to cut out of this one block. And to do this, I've clamped on this fence to the drill press, put in these 2 lines, and I can register the end of the block with these 2 lines this way, flip the block, and then do the other 2. And I have to do it from both sides because this bit isn't long enough to go all the way through. Even though it's a little time consuming now, it's going to be way more time efficient to do that now than drill each sidebar individually. So now that I've got all of the holes drilled for the little wiring grommets, I can go ahead and cut the slots in the top and bottom of these blanks, and then you can probably see where I'm going. We can then rip thin strips and get our individual sidebars that way. So I've actually gone and I'm using my plans. These plans are available on my website if you're interested, so I'm not going to go into too many dimensions in this video. I just want to go over the techniques I'm using to actually make these parts. So I've built this jig, this nifty little jig that rides on the fence of my table saw. And this will allow me to safely hold these blanks as I run them over a dado blade. And I've set the width of that dado stack to 3/4 of an inch. And there's a lot of setup here, so I'm going very slowly and using a test piece. I've got my calipers because I want to make sure that that dado stack is cutting directly in the middle of this blank, that it's the perfect width, and that I'm cutting to the perfect depth. And that way I can make one pass for each of these moving forward. Now I am pretty happy with the way I designed these frames. All of them get the same slots cut into the top and bottom, no matter if they're for the top frame or the bottom frame. And that is how you make just over 100 sidebars in a couple hours of work. Now, obviously, not all of these will be ideal to use. A couple will have knots or splits in them, so I always like to make a few extra. But now I've got all my sidebars ready to go, and they all have holes drilled in them. They've all got the slots. I'm super happy in the way I was able to do those processes early on, and that way I don't have to make each one of these individually, which would just be a nightmare and near on impossible. So the next step is to start making those cross pieces, the top and the bottom bars, and then the hanger on top, and that's when we'll get into some of the dovetail work. So let's do that next. So to make the rest of the pieces for these frames, I'm going to be using this 1x12 piece of pine. I've gone with a rough sawn board, simply because it's about half the price as a finished board. It's about 8 feet long, and I can get all the pieces I need to make 25 frames, which works out really well because that's what a hive holds. But this board does come with some texture on both sides, so we're going to plane that out just as I did with the sidebars. But one thing I wanted to mention is, since this board is a little bit of a lesser quality, you want to really take time and find one that doesn't have many knots and isn't very bowed or warped. That's going to save you a lot of hassle when you're actually milling up these pieces. The actual milling's pretty boring. We're just cutting out rectangles. We'll come back to do the actual dovetailing for the top and bottom bars, because that's the exciting part. So I just finished cutting up all of the horizontal pieces for all the frames. I have a few extra. You at least need 25 1/4-inch thick pieces and 75 1/2-inch thick pieces. And I basically made those by taking that pine board, running it through the planer until it fit well into the sidebars that I had cut previously. And then I could cut sections to length and then rip all the pieces I need on the table saw. So I've got all my parts here ready to go, and I'm now going to set up to cut the dovetails for the sliding dovetail top and bottom bars. So I've got a 14-inch degree dovetail bit. This bit is slightly special. Most dovetail bits you'll find are only 7 degrees. So this one flares a bit more than usual, and that just helps prevent the frames from slipping down. Since I'm going to be cutting a loose dovetail joint anyways, I don't want there to be much vertical slop. And I will mention that I'm cutting a loose dovetail because beehives are very moist places, and so this wood will swell with the moisture that the bees produce, and I don't want these dovetail joints seizing up on me. So we're going to set up this router table with my dovetail bit, and then we'll get to cutting those dovetails. I now have all of the pieces, and I can start assembling these frames. Now I want to point out how these dovetails fit, because the fit's pretty important. You don't want them too tight, because as the wood swells with moisture, it's going to expand and this joint is going to get tighter. So I like a nice loose fit, but you don't want them to be able to pull apart a whole lot, because that presents its own challenges, and mites can get in there and hide, and small hive beetles and such. So I've got a nice slip fit. There's not much slop, but they slide nicely, and you can see there's only 3/4 of an inch for the bees to traverse between the frames. So that's a lot better than the 1.25 inch I had in my previous design. I also want to show off that I cut two small grooves. This is for the top bar, and this is for the dovetailed top bar. I cut little slots, and that's for putting foundation in. Or I'm not a foundation user, so I'll be putting starter strips in there. But these are 1/8 of an inch wide, 1/8 of an inch deep. I can cut a strip, coat it with wax, and glue it really easily in here. So that's gonna keep everything nice and centered and make things super easy. But I'm excited. I've got all these pieces now. Off camera, I cut the top hangers. These are going to be what the frame hangs from, and also forms the roof of the hive. There's no gap in between these hangers. They're going to butt up right against each other. So I'm excited to have all these pieces ready to go, and now I got to start the assembly of them. I've got a small pin nailer here, some 18 gauge, 1.25" little brad nails. These are a little bit long. You could probably get away with something shorter. Probably 1 inch would be ideal, but these are going to work out fine. I've got all my pieces within easy reach. I can just grab. So I'm going to glue these together and use these pin nails just to hold them while the glue dries. The glue will be what gives the most strength to these joints. So these pin nails aren't exactly structural. They're there just to hold these frames as the glue dry. So keeping that in mind, it's a pretty assembly line process. I'm just going to start cranking these out. Soon enough, we'll have 25 frames. Let's do it. Well, that just about brings us to the end of the build on these double deep frames. I've got a nice stack of them over here to the side of me, 25 ready to go in a brand new hive that I'll be building next. I did add a few more things that I wanted to point out. I put on these little spacer blocks on the bottom frame section, and that's just to help maintain that bee space, a nice 3/8 of an inch in between each frame. I also added the top bar, the hanger, obviously, just with a few brad nails and some glue. And the last thing I added was 2 starter strips. Since I don't use foundation, these are wax-coated pieces of wood that I simply glued in there, and they'll help encourage the bees to start building their comb in the middle of the frame, as opposed to wonky, in between, cross comb, all that jazz. I hope you found this video interesting. Maybe you learned something, or maybe you're just curious about what I was up to with these wacky looking frames. And if you just liked the video or are interested in my build, I hope you'll consider subscribing. I plan on releasing a video soon detailing the full hive and that build as well. But that's kind of all I have to say on frames and these double deep frames. So until next time, happy beekeeping, and I'll see you in the next one.